So today we're going to review for Standard 4, which is all about exponents and roots. And the first concept is multiplying exponents. When we have x to the second power, or x squared, multiplied by x cubed, we add these exponents. So it becomes x to the 2 plus 3, or just x to the fifth. The same rules apply if we have negative exponents. Do we have the same base? Yes, the base is 2 for both of these terms, and the exponents are a positive 2 and a negative 3. When I add those together, 2 plus a negative 3, which is the same thing as 2 minus 3, I get 2 to the negative 1. Another way of writing this, since we have a negative exponent, is that 2 to the negative 1 is the same thing as 1 over 2 to the first. If we want to get rid of our negative in the exponent, we put it on the bottom of a fraction. What about if we have y to the fourth multiplied by y to the negative fourth? When we add those exponents, we get 0. Anything to the power of 0 is always just going to be 1. The next concept is dividing exponents. The rules are similar, but this time we subtract. So for example, if we have x to the fifth power divided by x cubed, we get x to the 5 minus 3, which turns out to be x squared. Another way to represent division is vertically, like this, via fraction. The property works the same. This becomes x to the fourth minus a negative 2. Notice when we are dividing by negative fractions, it's almost as if we are adding. This becomes 4 plus 2. So our new exponent is x to the sixth. The next concept, working with exponents, is a rule called power to a power. And this occurs when we have a base like x that is squared inside of parentheses. And notice outside of the parentheses we have an exponent of 3. So this is x squared to the third power. To simplify this, we multiply. So it becomes x to the 2 times 3, or x to the sixth. This rule can be chained. So for example, if we have v squared, which is then cubed and then multiplied to the fourth power, raised to the fourth power, we would multiply all of these numbers. So it becomes v to the 2 times 3 times 4. 2 times 3 is 6, times 4 is 24. That's called power to a power. You do that when there's parentheses. The next concept is simplifying radicals, or taking a basic square root. When we take the square root of 4, for example, we are looking for what two numbers, when you multiply them together, will give you 4. And the traditional answer is just 2, which is correct. 2 times 2 is 4. But there's another answer. Negative 2 multiplied by negative 2 also gives you 4. So a quick way to represent both of these answers is to write this as plus or minus 2. This symbol, plus or minus, means that there are two answers, a positive 2 or a negative 2. What about when we are multiplying two different radicals? Well, those two numbers can be converged under the same radical and it becomes the square root of 6 times 6, or the square root of 36. And this we can simplify because 6 times 6 is 36, and our answer is plus or minus 6. When we are dividing square roots, we can split the entire square root into 2, and it becomes the square root of 36 divided by the square root of 12. This number on top we can simplify, and it becomes 6. On the bottom, the square root of 12 cannot be simplified, so we leave it like that. So what about when we have a problem like x to the fourth power multiplied by y squared divided by x squared times y? Well, we can actually take each base variable separately. So for example, x and y separately. And for x, this becomes 4 minus 2, since I'm dividing the x's. And for y, this becomes 2 minus 1. So I can simplify this to x squared y.